Hi, in this lesson, let's go through this warm-up that's at the top of your notes for today. Mr. Williams wrote the following expression on the board, b to the fifth over b to the negative 5. Xander thinks that the expression can be simplified to 1 because of the zero power property. Do you agree or disagree? If you disagree, what should the answer be? So before we look at the zero power property, let's think about that negative 5, the negative property. That b to the fifth over b to the negative 5, the b to the negative 5 is going to move that b to the other side of the fraction. So it'll actually move to the top of the fraction and be another b to the positive 5. And then we have exponents on our variables, not outside of parentheses, so we're going to add those two together and get b to the 10th. So he says it's going to simplify to 1. I am not going to agree to that because I see that it simplifies to b to the 10th. Okay, that is not equal to 1. I am going to disagree. The answer should be b to the 10th. Okay, let's look at number 2. 3 students simplified the expression shown below. Circle the name of the student who wrote an equivalent expression. So when I look at number 2, the first thing I'm going to do is I'm going to regroup everything and I'm going to move those negative exponents to the correct side of the fraction bar. Okay, so if you see what I did here, my 12 over 3 is still good, my r to the 9th, I took that r to the negative 2, I moved it to the top. I took that s to the negative 8, I moved it to the bottom. I have this s to the first still down here. And then over in the second fraction, I took that s to the negative 3, I moved it to the top, and when I did that, there's nothing left down here. So it is going to stay a 1. Then I just regrouped everything. I took my 12 and my 2 and I put them next to each other. I took all of my r's and I put them next to each other. And then I did the same thing on the bottom. I didn't need to write multiply by 1 because that doesn't change anything. So now that I've done that, I can simplify this further. So I did 12 times 2 to get my 24 over my 3. 9, 10, 11, 12, 13, 14, 15, r to the 15. And then my s cubed stays s cubed, and on the bottom my 3 stays a 3. S to the 8, s to the first becomes s to the 9th. So then we're going to reduce that 24 thirds. 24 divided by 3 is 8. And we're going to do our subtraction here. Our quotient rule says 3 minus 9, which is negative 6. So I have 8 and negative 6. My r doesn't change. And then that negative 6, I'm going to move that to the other side of the fraction and put it underneath. So I end up with 8 r to the 15th over s to the 6th. When I look at Tamisha, Lacey, and Forrest, I can see that Forrest has the correct answer. All right, let's look at today's objective. Today we're going to simplify numeric and algebraic expressions using laws of exponents, and we will apply all of the exponent rules to a given expression. So we're going to practice applying the properties of exponents we've learned so far to simplify without negative exponents. We are going to apply the power of a product rule, power to a power rule, quotient rule, negative rule, and zero rule. So when I start with number 1, oh, sorry, I'm going to give you 2 minutes to work on that. You should be working on problem number 1 and then problem number 2. Problem number 1, group those y's together, group those z's together, simplify them. Problem number 2, you have that negative exponent to take care of. About 1 minute remaining. Hopefully you are on problem 2. right, let's look at our answers. On number 1, I'm going to group those y's together, and I'm going to group the z's together. So when I do that, I'm going to apply the quotient rule, which says I'm going to subtract the exponents. 4 minus 2 is 2. For the z's, I'm also dividing, so I'm going to use the quotient rule, which says I'm going to subtract the exponents. 3 minus 2 is 1. And remember, you don't have to write the 1. It can be like a little secret ninja right there, where you don't see it at all. So the answer to number 1 is y squared z. Let's look at number 2. On number 2, really the only thing I have to take care of is moving that x to the negative 4 underneath. Okay, I'm going to use my negative exponent rule that says move it to the other side of the fraction. My negative 5 and my y cubed will stay up on top. There is number 2. Let's look at 3 and 4. Take 2 minutes to solve 3 and 4. About 1 minute remaining. Hopefully you're on number 4. All right, let's look at the answers to number 3. Number 3, I see the y to the negative 1, so I'm going to apply the negative exponent rule, which says to move it to the other side of the fraction. So that y to the negative 1 is going to move to the top and become y to the positive 1. My x cubed and my z can't be grouped with anything and don't have anything to change with them. So this is going to be my answer. You can omit writing the 1 on the y, like a little ninja. Number 4, I'm going to group. I'm going to do my 12 divided by 3, which is going to give me 4. Then I'm going to use my quotient rule, r cubed minus r to the first, which is going to be subtraction. 3 minus 1 is r squared. Then I'm going to again use my quotient rule. S to the 7th over s to the 7th is s to the 7 minus 7, which is s to the 0. Then I'm going to apply my 0 power rule that says anything to the 0 power is just 1. Then I'm going to use my quotient rule again for t to the 5th over t to the 4th. 5 minus 4 is t to the 1st. Then when I group, again, 4 times 1, that's just 4. And then I have my r squared and my t to the 1st, which I can just write as t. So the answer to number 4 is 4r squared t. Let's take 2 minutes to do 5 and 6. About 1 minute remaining. All right, let's go over number 5 and number 6. When I look at number 5, first I see I have two variables that have negative exponents. So I'm going to apply the negative exponent rules, and I'm going to move those to the bottom of the fraction. I also have a variable that has a 0, so I'm going to change that to a 1. So all I'm going to have left up on the top is just the 5, and on the bottom I'm going to move that x to the negative 2 to the bottom and make it x to the positive 2, and y to the negative 3, I'm going to move that to the bottom and make it y to the positive 3, and that z to the 0 is times 1, but remember, if you're multiplying by 1, it can also be a secret ninja, and it doesn't have to be there. So my simplified version is 5 over x squared y cubed. Let's look at number 12. I'm going to group again. 12 over negative 9, I'm going to put that in my calculator and get negative 4/3. K to the 5th over k to the 2nd, that is my quotient rule, so I'm going to subtract those exponents. 5 minus 2 is 3, so k to the 3rd. Then m to the 3rd over m to the 3rd, I'm going to use my quotient power, and I'm going to subtract my exponents. 3 minus 3 is 0. But I'm also going to apply the 0 power rule that says that anything to the 0 power is just 1. Then I'm going to group my n's, n to the 6th over n to the 6th. I'm going to use my quotient rule and subtract those and get n to the 0 power. And then I'm going to apply that 0 power rule again and get another times 1. So then when I look at this, I know, I'm going to put it back, negative 1 times negative 1, when you're positive 1 times positive 1, I know when I'm multiplying by 1, it's not changing anything, so you don't have to write them. My answer is negative 4/3 k cubed. Let's look at 7 and 8. Take 2 minutes to do 7 and 8. About 1 minute remaining. If I look at number 7, I can see on number 7, the whole thing has been raised to a 0 power. So that means that whole thing is using the 0 power rule. If I have anything raised to the 0 power, that whole thing is just 1. Done, simple. 8, there's a little more work I have to do on 8. I have to raise everything in here, the negative, the 3, the x squared, the y to the negative 3, the z to the negative 4. Everything has to be raised to the 2nd power. So let's look at that. When I raise the negative to the 2nd power, negative times negative is positive. When I raise the 3 to the 2nd power, 3 squared is 9. When I raise x squared to the 2nd power, that 2 is outside the parentheses, so we're going to multiply. 2 times 2 is x to the 4th. The y to the negative 3, again, this is outside the parentheses, so I'm going to multiply negative 3 times 2 and get y to the negative 6. The z to the negative 4 to the 2, again, I'm going to multiply the negative 4 times the 2 and get z to the negative 8. Okay? Then the next thing I'm going to do is I'm going to work with my negatives and apply the negative property that says move them to the other side of the fraction and change the signs to positive. So I move my z to the negative 8 to the top and my y to the negative 6 to the bottom and make those exponents positive. Also, you'll notice the plus sign here, I didn't write it over here. You only have to write negatives, because if it's not written as a plus, you know it's defaulted to a plus. Okay, so that is my final answer to number 8. All right, let's talk about scientific notation. You may or may not have seen this already in your biology class, or you might have seen it in 8th grade very briefly. So let's talk about what scientific notation is. Sometimes numbers are just so big or so small, they're difficult to write. They have so many zeros attached to them. Okay, so they're written in scientific notation. Our decimal is moved so that there's only one digit on the left. Okay, on the right there can be lots of digits, but on the left side of my decimal, there's only one digit. Okay, then to indicate how many times we moved our decimal from where it originally was, we are going to multiply that by an appropriate power of 10. So when I see 5.7 times 10 to the 7th, 10 to the 7th is going to be a really big number because it's 10 times 10 times 10 times 10, 7 times. So it's a really big number, which means if I'm multiplying by a really big number, then I am going to be making this number bigger. So that means I want to move the decimal to the right so that this number, right, if I move it one place, now it's 57. If I move it 2 places, now it's 570. The more to the right we move it, the bigger that number is going to get. So we want to move it 7 places to the right. So I'm going to start with that 5.7, and I'm going to move the decimal 7 places to the right. So I'm going to move it to the other side of 7, that's 1, and then 2, 3, 4, 5, 6, 7. Okay? To make it easier to kind of digest what we just did there is remember every 3 places over to the left from the decimal, you can put commas, and now I can see that this is 57 million. That's a big number. Okay? If we're raised to a negative exponent, like on the next one, remember that's like 1 over 10 to the 7. So that means we're dividing by 10 to the 7 really, if you think about it, right? 1 over, we're putting it over the 10 to the 7. So we're dividing by that really big number, which is going to make this 5.7 really small. It's going to move our decimal to make it even small. Instead of $5.70, I move it once, and now I'm only 57 cents, right? I move it again, and I'm only 5.7 cents, right? So we're going to be moving it to the left to make it even smaller. So notice I'm going to write it way over here, and then I'm going to move it 7 places to the left. So first one is going to be when I move it to the other side of the 5, and then I'll add zeros. 1, 2, 3, 4, 5, 6, 7. And then a lot of times you'll see in the calculator, if you were to do this, it's going to give you, put the extra 0 in front of that decimal. So 1, 2, 3, 4, 5, 6 zeros here, just like I had 6 zeros here, because I had to first move that decimal past one number before I started moving it the rest of the 7. Okay? So let's try going the other direction. Can we take a big number with lots of zeros and turn it into scientific notation? So the first thing I want to do is I want to put my decimal in the right place. I can only have one number to the left of it. So this is going to become 3.25 times 10 to the something. We have to figure out what that something is. So if I move that decimal where it's supposed to be, I can see that I'm moving it to the right to get my final answer. I need to move it this direction to get it where it's supposed to be when it was here. Okay, so if I'm moving it to the right, I know this value is going to be big, but how big is it? It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We move 10 to the right, so I'm going to raise this to the positive value of 10. Okay, when I look at the next one, I can see that's a really tiny number. Again, I only want one number in front of my decimal. So I'm going to put 6.87. If that's where my decimal is, right there, I need to figure out how many places I moved it to get it back to where it's, so it's here right now. How many places do I have to move it to the left to get it back where it originally was? So let's see. I have to move it 1, 2, 3, 4, 5, 6 places to the left, which means negative. So to the -6th power. Sometimes you're going to be asked to simplify quotients of scientific notation, like this one. When I do this, I think of it doing it just like we did with the grouping. If I had 8x to the 5th and 4x to the 3rd, I'm going to group these together and treat them as two separate fractions. So I'm going to have my 8 over my 4 times my 10 to the 5th over 10 to the 3rd. And then I'm going to reduce them separately. So 8 divided by 4 is going to give me 2. And 10 to the 5th over 10 to the 2nd, I'm going to apply the quotient rule that says subtract, and that's going to give me 10 to the 5 minus 3 is 2. So that's the first one. Again, same thing. I'm going to separate that 3.6 over that 1.2 times the 10 to the 4th over the 10 to the 7th. I'm going to simplify the 3.6 divided by the 1.2. Feel free to do that in your calculator. You get 3. Then I'm going to apply my quotient rule and do 10 to the 4th over 10 to the 7th. 4 minus 7 is a -3. And in scientific notation, we generally will leave the negative exponent as it is. Okay? And then the last one over here, I'm going to separate it into 2.5 and 0.5 times 10 to the 3rd over 10 to the -4. And so that's going to give me 2.5 divided by 0.5. Do that in your calculator. It's going to give me 5. Times 10 to the, I have to subtract 3 minus a -4. I'm going to write it off to the side just to make sure I don't make any mistakes. 3 minus a -4, what's going to happen right here? When I do 3 minus a -4, that's going to turn into a plus sign. So really that's 3 plus 4, so this is to the 7th power. 5 times 10 to the 7th power. Okay? All right, we do have a quiz tomorrow. Okay, so for our quiz tomorrow, make sure you're familiar with your power of a product rule. Add them together. Your power to a power rule, multiply them if your n is outside, your exponent's outside of parentheses. Quotient, when you're dividing, you subtract. Your negative exponents, move them to the other side of the fraction and change the sign. And your 0 power, anything to the 0 is 1. Okay? Hopefully this helps strengthen those properties that we've been working on the last 4 days, and you will be ready for your quiz tomorrow. Thank you so much for watching.